nuclear science and engineering and manufacturing company. We're based in Adelaide, so our philosophy is to extract radioisotopes, often out of waste sources, and purify those and direct them into areas of value like nuclear medicine, supply chains, but also space and defence areas. So on the space and defence side, we're looking to create opportunities in nuclear, in power. So at the moment, power or long-term power is somewhat limited by the current technology that's around, and we're seeking to change that.
I understand. So you want to make all the space, underwater, and defense missions longer? Do you know by how much longer would you make them?
So at the moment, we're targeting opportunities in the autonomous sensor area, where a lot of technology at the moment is around surviving for weeks, perhaps months, where if you access nuclear or radiation or radioactive materials, you can take that lifetime out to months, years, even decades, depending on the application, like space applications in particular.
Okay, so pretty big difference. And who would you sell it to? Like, who would be your clients? The Defence Force, space agencies?
Yeah, so pretty much all the Allied Defence Forces, space agencies around the world, where they're interested in, I guess, longer term power. Where the further you get away from Earth, the less there is from an energy perspective around sunlight for photovoltaic. So, sort of nuclear batteries can operate anywhere, endurable, are very durable. So that's sort of opening up plenty of applications in those spaces.
And I see that to move from prototype to commercialization, you build a partnership with Adelaide University and the Additive Manufacturing Research Centre. Can you tell us more about that? What are they bringing to the table?
Absolutely. So entX has developed a Betavoltaic battery that over the last 5 years in collaboration with Adelaide University. It used to be the University of South Australia and the University of Adelaide, that's merged now into Adelaide University. So with those team members and those scientists there, we've developed technology, and just recently we've transitioned into production relevant, process. So we've internalized the technology that's been developed. We've developed a process in our own radiation labs here in Adelaide, and we're looking to go through a process of qualifying that for production. So that's where the additive manufacturing CRCs come in, through their support, with supporting Adelaide University support those activities. So as we go through this year, we're going to be moving from, a prototype process into something that's more representative of something we can actually produce from a production perspective, and start handing those things to customers.
Okay, and so just before commercialization, I guess you talked about production, and I assume you have specific materials that you need, I guess essential ones. What are the by the way, I know you have a background in mining, so what are the materials you absolutely need and that you would need over the long run?
Well, radioisotopes are our most important ingredient. So our product is somewhat agnostic to the type of radioisotope. So basically we fit the radioisotope to the actual application. So we're looking for something that needs to survive months. We can choose a radioisotope with a short half-life. But if we need something that survives many years, we need to access longer half-life radioisotopes. Now we're accessing beta emitters, so beta radiation is what we're harnessing. Relatively safe materials. So we've got a strong collaboration with ANSTO in Sydney, and many of our radioisotopes are coming from them. And some of our sources are also coming from waste, as I mentioned earlier. So that's probably the most important ingredient, and the hardest to come by, and the hardest to use, the hardest to handle. But we're well versed in how we handle radioisotopes from a safety and regulatory perspective here.
How do you find them here in Australia, or how do you develop them?
We've highlighted a few radioisotopes that are very useful for the particular applications we're chasing, and we can work with the team at ANSTO, where these materials can actually be irradiated in the reactor in Sydney and can come out and be used for us.
Okay, understand. So maybe one last question. So you're looking at 14 months for the commercialization project. What is the next step? And if someone's interested in your project, could they invest? Could they help you in any way?
Yeah, definitely. So always, it's a 14-month project. So for for the rest of the year, effectively, we're going to be going through what we call a product and process validation, I guess, method, where we ensure that our process and product is capable. We start producing multiple parts for testing, multiple parts for a customer evaluation, as we start scaling up towards the end of the year to actually be able to put these into customers' hands. There's a lot of work to do between now and the end of the year to do that, but we're well funded to do that, we're well resourced to do that, and it should be a good project.
Okay, I know I said last question, but maybe one more. You talked about funding. What is your main source of funding? Is it grants, for instance?
Yeah, we've been very successful at obtaining government grants over the last 5 years. So the project was originally funded through a cooperative research centre project. We've been lucky enough to get some other Australian government prototype funding, and that's been extremely useful for us to get us to where we are today. entX is a public non-listed company, so we do our capital raises, and I guess we get funding from our shareholders to do that. So we're well funded to be able to, I guess, hit our targets for the rest of the year.